Hello, calculus students and seekers of general truths. I am going to show you how to do this antiderivative here, but I'm going to show you a couple of approaches, and I'm going to show you a dead end. All right, and it seems very silly to show you a dead end, but I assure you that sometime in your work you will run into a dead end like this, and you will need to find a way out. So let's experience what it's like. So most people will perhaps do something like this. They will, multiply out the bottom. So that's going to be x squared plus 2x plus 1 times dx. And then we're going to take, if you look at the top here, the top's 2x it looks kind of like the derivative of the bottom, x squared, right? So we will do u is equal to x squared plus 2x plus 1 du dx. Oh, let me write my handwriting better than that. So then du dx will be equal to 2x plus 2, right? And then we can make our substitutions. Let's see here. We have our denominator here, x squared plus 2x plus 1. That's just going to be u. Right? And then the numerator, we have a 2x up here, right? And then we have a dx, and then let us try and solve for dx down here. So, well, what can we really do? We can say du dx minus 2 is equal to 2x, right? But this becomes very, very tricky and difficult to try to get rid of all of this stuff. All right, so I hope you wrote this down in your notes, or at least made a very careful mental note of this. Lots of people will run into these sort of dead ends. And so we have to approach this problem in a slightly different way. So let us attempt, a second try at this problem. And so this is 2x over x plus 1 quantity squared dx. Okay? And this time, rather than using the entire denominator as my u substitution, I'm just going to use the inside part here. So we're going to say that x plus 1 is equal to u. And the derivative of this is du dx is equal to 1, right? And therefore, du is in fact equal to dx. And we've seen in previous problems examples like this when we end up with the derivative of our substitution expression turns out to be just 1. What we're actually doing here is not the reverse chain rule. Rather, it is a transformation. So let's make these substitutions, and then we can see why. So we take this expression, right? Our denominator now, instead of x plus 1 quantity squared, is just going to be u squared. Okay? And then I'm going to take this 2 here. I'm just going to pull it out to the front, right, since that doesn't change a whole lot. And then I'm going to have left x. Okay, so I have here x and dx. Actually, dx is also easily resolved, right, because dx is equal to du. So the real issue is, how do I get rid of this x? Well, x plus 1 is equal to u. Therefore, u minus 1 is equal to x. So this becomes u minus 1. Okay? Now, let's just think a little bit about what this function really means here. What exactly is going on, right? So graphically, if we look at the function 2x over x plus 1, the graphs look like the following. This red right here is 2x over x plus 1 quantity squared, and the blue is 2u minus 1 over u quantity squared. So you can see that the blue and the red are just transformations of each other. What we're really doing here is we're altering the original problem a little bit using transformations. And that actually makes the problem easier to solve. Okay, so this is where we're using integration by substitution, but not as the reverse chain rule, but rather as a transformation problem. So let's continue and finish this out now. So we can actually split this up as follow. This is going to be u over u squared minus 1 over u squared du. Okay? And then we can extend that a little bit more. This is the u times 1 over u minus u to the negative 2 du. Okay? Let me change up some colors here so we don't get all mixed up. And so this will become 2 times the natural log of the absolute value of u minus the antiderivative of u to the negative second is u to the negative first time, or divided by negative 1, so that makes this a positive again. All of this plus our constant. And then let's make our substitutions back. This becomes the natural log of the absolute value of x plus 1 plus u to the negative 1 is just 1 over u, 1 over x plus 1. And all of that, and don't forget to add our constant. Okay, so this all right here, convoluted and crazy as it seems, is in fact our final answer. Okay. And there you have it, a fairly complex example of how do we use integration by substitution along with some properties of the derivative of the natural log function. Right? And again, I want to emphasize this is not the reverse chain rule. This is a transformation problem. All right, now I'll finally end this video and we can move on to the antiderivative of e to the x and some other things that involve different bases.